This is chapter 5.5, exercise 1 through 12, and 25 and 26. Section 5.5 in our book has to do with the law of sines. And the law of sines is this, that if you have a triangle, the sine of angle A is to the length of side A is the same as the sine of angle B compared to its opposite side B, which equals the sine of angle C to its opposite side C. And this was developed by Islamic mathematicians in the 10th and 11th centuries, and then really condensed and made more accessible by Regiomontanus, a German mathematician, in the 15th century. So in exercise 1 through 4, solve the triangle. And solving the triangle means finding all sides and angles. And here we have angle A 60 degrees, angle B 45 degrees, and we don't have angle C. We can find angle C if we take C is equal to 180, because we have 180 degrees. And then we're going to subtract out angle A, which is 60 degrees, and subtract out angle B, which is 45 degrees. And that's going to be angle C is equal to 180. And we're going to take minus 60 and 45 is going to be minus 105 degrees, which equals 75 degrees. So that's going to be our first thing solved for, angle C, 75 degrees. Now we need to go about solving for our unknown sides, and we can start really with any of them. I like to take the smallest one first. We don't have much choice in the matter here. What you're looking for, law of sines, if you have a side that's opposite an angle, that's really what you're looking for in a law of sine solution. If you don't have an angle opposite a side, there has to be, could be law of cosines or maybe unsolvable. And law of sines works with all triangles, but is particularly useful for non-right triangles where there's not a 90-degree angle in it. So let's go ahead. We're going to use this ratio here, and we're going to solve for side A. And side A, which we do not know, is to the sine of 60 degrees, as side B, which we do know, is 3.7, is to the sine of its opposite angle, which is 45 degrees. And so if we cross multiply the sine 60 degrees, we have side A is equal to 3.7 times the sine of 60 degrees over the sine of 45 degrees. And we're going to go to our calculator. Key thing in calculator is being set in degrees mode. So I'm going to go to settings and document settings, degrees. Okay, this is the TI Inspire CX calculator. We get to our page here, and we're going to take 3.7 times the sine. We have the trig button here, sine of 60 degrees over the sine of 45 degrees. So we go sine 45 degrees. Looks like everything is in place. And we have a distance of 4.531, rounded to 4.532, rounded to the thousandths place. So A is approximately equal to 4.532. That is side A. And the last one we're going to get is side C, and for that we take C over sine 60 degrees. Now at this point, having solved for side A, we could have used A as a reference, but side C is to, actually that's going to be 75 degrees, isn't it? And there we go. Is to 3.7 over sine 45 degrees. Sine 45 degrees. There we go. And then we go ahead and cross multiply. So we have C is equal to 3.7 times sine of 75 degrees over the sine of 45 degrees. So we go to our calculator again, and everything's going to be the same, except in the numerator we're going to be multiplying by the sine of 75 degrees instead of by the sine of 60 degrees. And we divide, as we did before, by the sine of 45 degrees. And for that we have 5.054, rounded to the thousandths place. Some people round to the hundredths place or to the tenths place. Make sure if you're rounding to, if you're using a preliminary answer that will later get to final answer, round as little as possible. Okay, next odd number problem, which is 3. We have this situation, and we look to, we have a length of 22 opposite an angle of 100 degrees. So that's going to be what we use. And we have this side C, which is unknown, opposite this angle of 35 degrees. So that's the first relationship we'll do. But before that, we can find angle B, can't we? Angle B is going to be equal to 180 degrees minus, we have 100 degrees for angle A and 35 degrees for angle C. And that's going to be 180 minus 135. And so angle B is going to be equal to 45 degrees. So that's part of our solution. Next, we're going to locate the sides as we did before. We're going to have, we want to find side C, and side C over sine 35 degrees equals side A, which is 22, over angle A, which is sine of 100 degrees. And so cross multiplying the sine 35 degrees, we have C is equal to 22 times the sine of 35 degrees all over the sine of 100 degrees. So we go ahead and go to our calculator. We have 22 times sine of 35 degrees over the sine of 100 degrees. And we have 12.813 as our length. So let's go back here. So C is approximately equal to 12.813. So that'll be our answer to side C. Next, we're going to go to solve for side B. Well, what we have as side B is to the angle of B, which is, or the sine of angle B, which is 45 degrees. So we're going to have sine of 45 degrees. Okay, and we're going to take our same ratio we had of A to angle A. So we have 22 over sine of 100 degrees. And what we're going to have is B, side B, is equal to 22 times sine of 45 degrees over sine of 100 degrees. Okay, and then we just make our calculation as we did before. And we have 22 times sine of 45 degrees over the sine of 100 degrees. And we get, that's going to be 15.796. So, there, 15.796. Okay, we're going to next look at problem number 5. This time we're not given a drawing, are we? We're going to need to create a drawing. At least I feel that it's helpful to create a drawing. But even before that, we have angle A and angle B, and we have side B. And so this side B, little b, is opposite angle A. So that is indicative that we have a law of sines application. Well, angle C is going to be 180 minus angle A, which is 40 degrees, minus angle B, which is 30 degrees. So that's going to be angle C equals 180 degrees minus 70 degrees. So angle C is going to be equal to 110 degrees. Okay, so now we can make some kind of drawing. I want to make these drawings. I like to make one as reasonably accurate as possible, and when I say that, I try to get something where I can see that, okay, we have a reasonable answer. So here I'm going to draw what I think is maybe about a 110 degree angle. So that would be angle C right there. And then we have these other angles. So we're just going to complete the triangle like this. And we have angle B is 30 degrees. So we'll say that's 30 degrees. And we'll say that angle A is 40 degrees. Okay, angle B is 30 degrees. Angle C equals 110 degrees. And we're given side B. Well, side B is this side over here. I'm going to mark in red, which is 10. So we're going to try to get side C first. And for that, we'll say side C, which we do not know, over the sine of 110 degrees is equal to the opposite sides we have are 10 opposite angle, this angle here, so I'm going to circle these here. So side 10 opposite the angle 30 degrees, so we have 10 over sine of 30 degrees. So what that means is when we cross multiply the sine 110 degrees, we're going to have side C is equal to 10 times the sine of 110 degrees over the sine of 30 degrees. I think the sine of 30 degrees is 0.5, but we'll just put this in the calculator. Okay, we have 10 times sine of 110 degrees over the sine of 30 degrees. And again, I have to remember the sine of 30 degrees is 1/2. So we get 18.794. So C is approximately equal to 18.794. Okay, the last thing we're going to get is we do not have yet side A. So side A, right here, so A is to the sine of 40 degrees as side B is to the sine of 30 degrees. Okay, so cross multiplying, we get A, side A is equal to 10 times sine of 40 degrees over the sine of 30 degrees. So we go to our calculator, 10 times sine of 40 degrees over the sine of 30 degrees, we get 12.856. Right, that's how it's placed. 12.856. One thing you look kind of as a check to see if you have a reasonable answer is the largest side is going to be opposite the largest angle. And here we have opposite our 110 degree angle, we have 20, we have 18.79 opposite our 40 degree angle. We have 12.856. So that should give us some idea that we have our answer right, or at least a reasonable answer. Problem 7. Well, we have a similar situation. Solve the triangle. We have angles A and B. We need C. So angle C is going to be equal to 180 degrees minus angle A, which is 33 degrees, minus angle B, which is 70 degrees. So angle C is going to be equal to 180 minus 33 minus 70, so that's going to be minus 103 degrees. So 180 minus 103, that should be 77 degrees. So angle C is equal to 77 degrees. All right, so we have those three angles. and that's going to be kind of an acute angle. I'm just going to draw an acute triangle like this. Okay, angle C, 77 degrees. So we'll say this angle C down here equals 77 degrees. Side C opposite, we have angle A, which equals 33 degrees. And side A, which opposite angle A, which we do not know. And finally we have angle B, which equals 70 degrees. And we do know side B, which is 7. So, employing our law of sines, we have this situation here where we have side B, which is 7, opposite 70-degree angle, and we can go for either angle A or C at this point. I like to go for the smallest angle first. So we're going to go for side A. So side A, which we do not yet know, is to the sine of 33 degrees. And that's equal to side B, which is 7, over the sine of our angle opposite side B, which is 70 degrees. So side A is equal to 7 times the sine of 33 degrees divided by the sine of 70 degrees. And so going to our calculator, we have 7 times the sine of, just to be sure, 33 degrees over the sine of 70 degrees. And so we get 4.057, rounded to the thousandths place. .057. Okay, just totally solved for all sides. We still lack, we have side B, side A, we need side C. So side C is 2 the sine of 77 degrees, as side B, which is 7, is to the sine of 70 degrees. Now, if we've done this right, by the time we figure this out, side C should be our largest, since side C is opposite our largest angle. So side C is equal to 7 times the sine of 77 degrees over the sine of 70 degrees. So we go to our calculator. 7 times the sine of 77 degrees over the sine of 70 degrees. So we get 7.258. Okay, there we go. Next, we're going to go to problem 9. Our next odd number problem. And here we have a situation where we have an angle opposite a side, but we don't have an angle opposite side B. So So angle B is what we're trying to find out. So we really kind of have some ambiguity here. So let's go ahead and just work this out before we even make a drawing. You don't need a drawing all the time. And so this time we have angle B, or the sine of, we're going to say the sine of angle B, and we don't know what angle B is to side B, which is 11. It's the same as sine of 32 degrees, which is the sine of angle A, or side 17. So cross multiplying, we have the sine of angle B is equal to 11 times the sine of 32 degrees over 17. And so we can go to our calculator and 11 sine 32 degrees, 11 times sine of 32 degrees, and we're going over 17. Divided by 17. So we get this number here, 0.342889. Okay. And what we have to do, and since we have sine B is equal to 0.342889, to isolate, to get this angle B by itself, we need to take the inverse sine of both sides. And doing that, we have the inverse of sine angle B is equal to the inverse sine of 0.342889. Okay, so we go to our calculator and we can do this. Now the inverse sine we get by going to our trig button and going down to where it says sine to the -1 power. That means inverse sine, and we can put our answer in, our exact answer, by pressing Control A and S. And for that, we get 20.053 degrees. So that's going to be the measure of our angle in degrees. Okay, and next, now we're able to get angle C. Well, angle C is going to be equal to 180 degrees minus 32 minus this 20.053. So we go ahead and put that in our calculator. 180 minus 32 minus 20.053. So we get 127.947 degrees. And now we can go ahead and find what side C is. And side C, which we do not know, is over the sine of 127.947 degrees is equal to our ratio we had earlier, which is this side A, which is going to be 17, over the sine of 32 degrees. So, and cross multiplying, we have side C is equal to 17 times the sine of 127.947 degrees, and we're going to divide that by the sine of 32 degrees. Okay, so going to our calculator, we have 17 times the sine of 127.947. What we can do is just, since that's the last number the calculator found, we're going to take a control negative sign for A and S, and then we're going to divide that by the sine of 32 degrees. So come down here, we have the sine of 32 degrees, and we get 25.298. 25.298. So we say side C is equal to 25.298. Here's an example of where you don't want to round your answer at all until the very last. So that's going to be problem 9. Next odd number problem 11. And here we have a similar situation. We have a side B, which is 14, opposite angle B, which is 70 degrees. And we have this side C, and angle C is what we do not know. And so, again, similar to problem 9, we're going to have the sine of angle C, which we do not know, over side C, which is 9, is equal to the sine of 70 degrees over side B, and side B is 14. Let's get 14 there instead. And so, working this out, we get the sine of angle C is equal to 9 times the sine of 70 degrees over 14. So here we go. We have back here 9 times sine 70 degrees over 14. And so we get 0.604088. Okay, so here we have the equation. Sine C, sine of angle C, is equal to 0.604088. And to isolate angle C, we take the inverse sine of both sides of the equation, and so we end up with C. Here on the left side, the inverse sine of sine cancel out, so we have angle C equals to the inverse sine of 0.604088. And so angle C, going to our calculator, is equal to the inverse sine, so we press this, inverse sine of, put control A and S, so we get 37.163 degrees. I'm going to put 1633. And so that's going to be one of our answers. We want to find out now what angle A is. And angle A is going to be equal to 180 degrees minus 70 degrees, which is angle B, minus angle C, which is 37.1633. So A is going to be equal to, we can go to our calculator, take 180 minus 70 minus, I'll put control A and S, and so we get 72.8367 degrees. And so now we can set up our ratio to find what side A is. Let's go ahead and box in angle A. And so side A is to the sine of 72.8367 degrees. And that's equal to a ratio of B, side B, which is 14 over the sine of 70 degrees. Okay, and so side A is equal to 14 times the sine of 72.8367 degrees, and that's going to be over the sine of 70 degrees. So working that out, we have 14 times the sine of this angle. Well, that was the last number calculated, right? So we can just put control A and S. That would be over the sine of 70 degrees. Here we have that. We have 14.235. That's going to be our side C, or side A. Right, 14.235. Okay. Next, we're going to go to the next on our problem, which is 25. In exercise 25 and 26, decide whether each triangle can be solved using the law of sines. If so, solve it. Well, what you're looking for is you're looking for an angle side or side angle side. Here in part A, 25A, you opposite the only angle you have an unknown. And opposite the sides you do know, you don't have an angle you know. And so you don't have a side opposite an angle. So for this one, you do not. This is what's called a side angle side case. So this would be no. This is a side angle side case. And for this, I will tell you that this is going to be a law of cosines application. Now in part B, well, part B is really even worse because you not only don't have a side opposite at this angle, the only angle you have 56, you just have another side. So this part B is entirely unworkable. So only two pieces of information given. So no, only two pieces of information given. So that's going to be part B. Just take a quick look at 26. And 26, it looks like you have this side of 81, that's side little a, opposite side angle A, which is 29 degrees. And then you can find angle C. I think this is a law of sines, part A. Part B is a law of cosines. I'll leave you to solve those. Actually, you can't solve part B. Anyway, good luck on your even number problems as a demonstration of your learning, and thanks for viewing.